Hey there! Today I want to take some time to talk about the differences between L1 and L2 regularization, two techniques we often use in machine learning to improve model performance by preventing overfitting. To start with, some of you may remember that I covered regularization in an older video that I'm not particularly proud of, so let me briefly revisit the key concept. Regularization is all about simplifying a neural network by encouraging its weights to be small. Why do you want that? Well, when our model is too complex, it tends to memorize the training data instead of learning general patterns. This leads to overfitting, where the model performs well on training data but struggles with new, unseen data. And by keeping the weight small, regularization helps reduce the model's complexity, making it better at generalizing. We can better understand this by looking at the loss function with regularization as being made up of two components: the usual loss, which measures prediction accuracy, and the regularization term, which penalizes large weights. This penalty term here helps keeping everything in check so that the weights of our model remain small, close to zero, and thus the complexity of our model is reduced, which prevents overfitting. Now, let's get back to the main topic of this video and let's talk about the key differences between L1 and L2 regularization. L1 regularization tends to produce sparse weights, meaning that many of the weights become exactly zero. This effectively ignores some features, which results in a simple model that can be easier to interpret. We can almost think of it as a way of deciding which features are essential and which can be discarded. L2 regularization, on the other hand, prefers to keep all weights small, but not exactly zero. Instead of eliminating features, it ensures all the weights stay balanced and small, leading to a more evenly distributed solution where every weight contributes at least a little. To better understand these differences, let's explore the mathematical shapes of L1 and L2 regularization through their respective equations. For L1 regularization, we add the term lambda L1 norm of theta to the loss function. This penalty uses the absolute values of the weights, which results in a diamond-shaped constraint when plotted. This diamond shape leads to more intersection with the axis, which explains why L1 tends to push some weights to zero, resulting in sparsity. On the other hand, L2 regularization adds the term lambda L2 norm of theta squared to the loss function. This penalty is based on the square values of the weights, which gives it a circular shape when plotted. Because of this smooth rounded shape, L2 doesn't create the same sharp intersections as L1, meaning that it tends to reduce all weights gradually without forcing them to be zero. This makes L2 a more gentle and well-rounded approach to regularization, where every weight is adjusted but still retains a small contribution. And that's basically it for this video. Please hit the like button if you found this video helpful, share your thoughts in the comments below, and don't forget to subscribe if you want to stay up to date with the content I create on this channel. Last but not least, I would like to give a big thanks to all the people that are directly supporting this channel, including my patrons and my YouTube members. And please consider joining them if you'd like to help me continue creating content for you. Your support goes a long way in making these videos possible. Thanks again for watching, and I will see you in the next one. Bye bye!